Hi Dave, this is Anne doing a small video to show you a bit a story about the PC board I'm sending to you. This is like a power supply project I'm working on, so let's focus on the Pheonix system that I was engineering back in 2004-2005. So ultimately this is one of the populated board we had assembled. And it's very simple, power supply switching with the LM2595 series from National for power supply. Also power input here. And of course, so you have RS485 interface with the Maxim chip. And of course, so CPU, it was it's 68 16 or something like that, the chip I was using with clock and some glue logic, of course, EEPROM there, and some RAM, and some IO interfacing here. So ultimately, it wouldn't start that board. So we didn't know exactly what was happening. Me and a partner were designing that, so we made a small board here to plug into the interface here. Just the interface that's doing the vertical bus thing that is involved with the stacking of these boards. And ultimately, so when using this board, we're able to trigger on an address. And ultimately, we found there was bus contention in there, so we didn't know what was happening really. So we asked the assembler company to just reassemble another board with less chips on it. Like all the interfacing board chips are gone, the RAM is gone also. So we had that, and when we realized that there was a problem with interpreting the actual data sheet of the CPU about the LSB or MSB being switched on with the address bus. So once that was solved, there was more problems anyway. The CPU wouldn't start; it wouldn't go to the FFE address to start for the reset vector. So ultimately, we involved the Future Electronics with that, and of course some rep in Dallas from Freescale, and they asked us for the schematic and the program and the BIOS here. And what they came up with, the story was that ultimately the chip, even though the spec sheet says that it can use the mode pins to have it boot from an external bus, like it is set up here, the chip can't do it. Disk mask and disk mask could not do it. It had to start from the inside the EEPROM and then jump to external access if we wanted to, but it had to be programmed as an embedded system first. So yeah, so they came out with an errata later on explaining that concept and that they would never make another mask to solve that, so that was a dead thing. So by the time we put all the money into the project, we shelved that ultimately, and a few months later we found out that they actually copied our system, I guess, with their Towers product that you can look on the actual URL I sent you about this. So that's basically it. For young players out there, as you say, make sure you read all erratas that's available on a chip that you plan to use, and ultimately make sure you have space in your budget to account for any debugging and some more problems that could arise. Else you're going to run out of money before you run out of bugs. Thanks.